Hi guys, so week number 9, it's looking like there's going to be 10 weeks. This is week number 9 and lesson number 1. And we're only going to have 2 lessons this week, so we'll have our live one today, our video one today and our live one on Friday. Our mission by the end of next week, so the end of week 10 before the Easter holidays, is to finish up with applied measure. So we finish off on Friday. We had a look at the at this last exercise here, corrected that, and I gave you a couple of questions to do in the revision exercise. So I asked you to do 2, 4, 6, 8, 11, 12 and 13 of the revision exercise, and as promised I have posted the questions to all the revision exercise out here on the right hand side. If there's any questions on that at all, you can ask me, but go through them, make sure you correct them all before you move on. But again, there was nothing new in that. It was just pi r squared, 2 pi r, length by breadth by height, volume capacity of cuboid, cube, triangle and cylinder, okay, and circle. Okay, so same formulas, but do correct them before you move on. You can pause the video now and do that if you so wish. Today though, we move on to the higher level, so back to book number 2, chapter 19, which is applied measure, but they call it perimeter area volume. So we've done perimeter area volume, it's the same thing. So just a few reminders, right, and I've put on a few notes here for you. So perimeter is the length of all the sides. Area is the amount of flat space, same definitions. To find the area of a rectangle, it's length by width. To find the perimeter, it's add the length and the width and the length and the width. Same for a square, except you don't have width, you just have 4 lengths. So the area is length by length, and the perimeter is all the way length plus length plus length plus length, or 4 lengths. Either one, so 4 times one of the lengths, or add the 4 lengths all the way around. Remember, in area you're looking at squared, centimeters squared, meters squared, kilometers squared. Same for a triangle, same formula, half the base by the perpendicular height to find the area of a triangle, and to find the area of a circle is pi r squared, or to find the circumference all the way around the outside is 2 pi r. Same formula, okay? Only difference between what we were doing last week and what we're going to do now is we kind of put shapes together. So we're going to have, like the way buildings are, you might have a rectangle shape with a circle, with a triangle on top, something like this. You might have a funny looking shape like this. So here's a square and here's a triangle, and they might ask you to find the area of something like this. So we have, if we want to find the area of this kind of shape, but we find the area of this first. This is going to be 6 by 6, which is 36 centimeters squared. So you can find the area of the square bit, which is 36 centimeters squared. And then we need to find the area of the triangle. And we know the formula to find the area of a triangle is half the base by the perpendicular height, but they don't give you that. They give you the height of the whole thing. But you know that up as far as here is going to, nope, up as far as there is going to be 6. So the rest is going to be 7. So half the base of it, so half the base of this is going to be 3. So they're going to have half of 6, or half of 6, which is going to be 3, multiplied by the perpendicular height, which we worked out here to be 7. So half of 6 by 7 is going to be 21. And then we add the area of the square to the area of the triangle to give you 57 centimeters squared. So you just work them out separately and add them together. One using so a couple of examples here. One using a circle. So you remember, if I wanted to define the area of a circle, you would say, all right, no problem, pi r squared. If I asked you to find the area of a semicircle, you would have said, all right, half pi r squared, or half the area of a circle. And that's what we're doing so far. But the problem is if it's a bit missing, so you have a small bit missing in the circle, like you see here, so there's only a bit taken out, how do we do it? So this is 3/4, so there's a quarter missing. So the shape is known as a sector of a circle. So a sector is a piece of the circle. So sector is a bit of the circle bound by 2 radii. So you're thinking, well, where's my radii? Well, there's one radii there, and then there's the other radii going down like that. So you have 2 radii. So if that's 7.2, this other one here is going to be 7.2. So if we find the area of a full circle, the formula to find that is pi r squared. The area of the sector then, so the bit you're looking for, it's not going to be a full pi r squared, it's going to be 3/4 of pi, there's 3.14, the radius is 7.2 squared. Into your calculator, that gives you 122.1 centimeters squared. So if they want you to find, if it was only looking to find half the circle, it'd be half pi r squared. If there was only 1/4 of a circle there, it'd be 1/4 pi r squared. But they want 3/4, which was 3/4 pi r squared. To find the perimeter of that then, remember the formula you use to find the perimeter is 2 pi r. Should be coming up now. 2 pi is 2 pi r. So what they're asking us to do then, well, we don't want to know the full perimeter, we only want to know 3/4 of the perimeter. So what they're going to do there is we're going to get 3/4 of 2 pi r. So you see how there's a bit of a lag for some reason on this. I'm just going to go out and back into it because there's a bit of a lag. Yep, there we go. So we have 3/4 by 2 pi r. So the formula for the perimeter of a circle multiplied by 3/4. And that gives you, when you throw it into a calculator, 33.912 centimeters. Not centimeters squared. Perimeter or circumference is not centimeters squared. Centimeters squared is for area. Okay, another one. So this is the length. So if we're looking to finish off that sum, then this is the length of the arc. So what we've worked out with our 33.912, we've worked out all the way around here, all the way around, all the way around, all the way around, all the way around, and we've got as far as there. The problem is what we haven't worked out is this bit in here from there to there. So if we're looking for the perimeter all the way around, if you were to drive that, if that was a big circle with a chunk taken out of it, you'd still have to go down 7.2 and across 7.2. So what we do is we take the circumference bit that we've added on with that we've worked out, add the 7.2, add the other 7.2, which is here and here, and it gives us 48.3 centimeters. Okay, right. Another example. Make it a bit smaller so we can see the whole thing. Okay, so a rectangular piece of card is shown. They want us to take now is pi is 22/7, and we're looking to find the shaded part. What's the area of the shaded part? So that green bit there in the middle. What's the area of the shaded part? Okay, so well, if we're looking to find the area of the shaded part, what they say is the total area minus the unshaded area. So if we look at our total, I'm going to draw a blue line around our total area. Our total area goes down like this, across like this, up like this, and across like this. So there's our total area. And what they give us there is they say, right, well, it's 26 centimeters is going to be our length. Our radius here, they give us 12.5. So going from here to the side is going to be 12.5. If that's 12.5, it means that the other side is going to be 12.5. So the whole length of this side is going to be 25 centimeters from here to here. So we can find our total area, so that the area of the whole rectangle, by multiplying 26 by 25, length by width, which gives us 650 centimeters squared. And these are, see the difference? You're working on an actual problem. If you were planning a football field with funny shapes on it, how would you work out the different areas of the different parts of it? So if we go down, so we know how much the total area of the whole square is, but we're still looking for the shaded bit. And to find the shaded bit, we have to find the area of the unshaded bit. Let's start with this semicircle job here. If we take the semicircle part, you know that the area of a circle is pi r squared. So the area of a circle is pi r squared, but it's a semicircle, so it's going to be a half pi r squared. And they told us to take pi as 22/7 up the top there, so a half pi r squared. Sub it in. into your calculator, and that works out as 245 and a bit centimeters squared in your calculator. Right, so we know we've now worked out that the area of this one here is 2, 4, 5, and 15 over 28 centimeters squared. So we have the area of that bit. For a triangle, it's half the base by the perpendicular height. So half the base by the perpendicular height. So we say, right, here's our formula here, half the base by the height. So it's going to be half, well, the base of it is going to be 25. So half of 25 by the height, which is 7. So the triangle is 87.5. So 87.5. So we've now worked out, there's the area of the triangle, there's the area of the semicircle. So what we can do is, we can say, right, let's work out the area of the unshaded region. Well, let's add our two answers together. 87.5 and 245 and 2/8. There's the area of the unshaded region, so the area that's not green. And then to find then the area of the bit that is green, well, we worked out earlier on that the area of the whole thing was 650. We take away the area of the unshaded bit, and that will give us the area of the shaded bit, which is 317. Okay, so you really got to take your time with these. Go step by step, nice and slow, and it will work out for you. Okay, and one or two more, because they're kind of. I imagine you won't find it too difficult, but it's just kind of reusing those formulas over and over again. And when you're using more than one shape at once, and you get a shape like this here now, a plan for a garden. And gardens are never perfectly rectangular. There's always bits jutting out of houses that make them not rectangular. So find the area of the garden. And the problem is with that garden is that it's not a shape. It's not a triangle. It's not a rectangle. It's not a cube. So you have to make it into something that you have a formula for. So what you're going to do is, and you see they do it here, they draw the line down and separate it. And now we have a triangle and we have a rectangle, and we can do something with that. We can find the triangle, or the rectangle is going to be 8 by 4, which is going to give us 8 4s is 32 meters squared, and we can get the half of 6 multiplied by the height, which we have, which is 8, which is going to give us 24 meters squared. And we can add those two together to give us 56 meters squared. So there's our area done. So you're all well used to finding the area of a triangle and a rectangle now. The next thing to go for then is part B. The garden is to be enclosed by a fence. A metre of fencing costs $6.50. So you're going to have to cover all the outside. So you're thinking about circumference or perimeter here. Find the cost of fencing. Okay. Well, first off, okay, we're going to need the length. So we know that if we're to take this shape, we know this length is 4 meters. We need fence for that. This is 8 meters. We need fence for that. This is 10 meters. We need fence for that. But we don't know that length there. So you know that if this is our triangle here, and we know this side is 8, we know this side here is going to be, well, if this part here is 4, this part here is going to be 6, 8. We can use Pythagoras theorem. So we have two sides. We need a third side. We can use Pythagoras theorem. And that's what they're doing there in the answer there. So they say, well, Pythagoras theorem is equal to, so c squared is a squared plus b squared. So just to show you, that's going to be c, that's going to be a, and that's going to be b down here. And they do, okay, well, c squared is equal to 8 squared plus 6 squared. 8 squared is 64, 6 squared is 36. So c squared is 100, get the root of 100, and it gives you c is equal to 10. So this line here is going to end up being 10 meters. Okay? So now we know that we have for our fencing, we need 4 meters, 8 meters, 10 meters, and 10 meters. Going all the way across. And they fill that in for us over here, 4, 8, 10, 110 like that. So if you add that up, then the perimeter all the way around the outside of that shape is going to be 32 meters in length. They ask us in the question, if it costs €5.60 for every meter, how much is it going to cost? Okay, so we take our 32 meters, 5.60 a meter, multiply them together, it's going to cost €179.20. Okay, last one is going to be this one here. The area of a circle is 201 millimeter squares. They're giving us the area at the start. Okay, so area of a circle. I haven't even read the question yet, but I know I'm dealing with pi r squared. That's the area of a circle. The area of a circle, so they're telling us that it's going to be 201 and a seventh millimeters. I want us to use pi as 22/7 this time. That's okay. We can sub in for 22/7, no problem. So what we're going to do is we're going to say, have a look down the left now. You're going, here's the area here. The area they gave us is equal to pi r squared. Okay, sub in for pi. So what you're going to end up with, r squared on its own, bring everything else over, and you end up with the 201 and a seventh over 22/7. That works all as 64. So r squared is 64, get the root of 64, which is 8 millimeters. Okay, don't worry about that method at all. Don't like it. Okay. Right, and that's the way it's going, right? So what I've asked you to do, I've given you quite a few. These won't be due now until Friday, because I know I said Wednesday, but I forgot we are not in school Wednesday because it's Paddy's Day, so it's not due until Friday. Okay, 3, 6, 7, 9, 11, 14, and 23, and I've ticked them. I've ticked them all for you as well, right? So this one here kind of starts quite easy. They want you to find the area. They give you the area in that sum, and they want you to find. So sorry, I forgot to move down. I'm doing it on the iPad. So there's your questions there, due for Friday. 3, 6, 7, 9, 11, 14, and 23, and I've marked them. This one here, question 3, they've given you the area. They want you to find the perpendicular height. So half the base multiplied by x is equal to 51. The same here. This is a square, is it? Yeah, x multiplied by x is going to be equal to 361. So x squared is 361. Find out x. 6, they give us this thing here. It's like is it a square or a rectangle? I'm not sure. What we're going to do, find the area of the shaded red of each of the following shapes. So we're going to have to find out the area of this in here. So if you find the area of the outside one, and then find the area of the inside one, take away from the other, it's going to give you the area of the red bit. This bit's tricky. I like this question. I'm not going to tell you how to do this because it's a nice question to have a go at, see if anyone works it out. Okay. After that then, I asked you to do question number 7. So question number 7 is about a pizza. You're looking for the radius of the pizza. So remember, if you're looking, they're giving you the area, so you're going to find r. Pi r squared is equal to 784. Work out what r is. And what is the area of one slice of pizza? Well, if you know the area of the whole thing, then it's an 8 slice pizza. We'll divide it by 8 to find the answer. Question 9 is a square tile with a bit missing out of it, a bit shaded in. Okay, so remember, you're dealing with a square here. You're dealing with a quarter circle drawn in, so remember, a quarter of an area. You're asked to find the area of the triangular untinted glass used in the window, area of the green tinted glass. Hey, no, I'm going wrong. Nope, you're going from A over here. These tiles are used, the following well space in the kitchen. How many tiles are needed to tile this space? So how many of these tiles are you going to need? It goes from here to here. And then it's working out a cost of the tile as well. So it's a nice question as well. It's question 9. After that then you're moving to 11. So you have a triangle inside a semicircle, very like one of the examples that we did. So quite challenging this, but it's a real world problems. things with glass windows and tiles and stuff like that. So you're going to be working out the area of this triangle, the area of the semicircle, half pi r squared, and you're going to be figuring out the shaded part here. And they're also going to ask you a bit about percentages. So what percentage is covered by the tile? So how do you go and get a percentage? After that then, and I think you've number 23 as well, which is a bit of a sector. So it's a bit of a circle. Okay, so where's the questions? I'll just go finish off on that one there. So there's your homework there for Wednesday. You'll probably get a lot of that done between now and the end of the hour, but put your best effort in. If you can do these ones, it's a guaranteed question every year, so well worth putting your effort in. This is the nitty gritty, the higher level stuff that I really need you to be able to do, and we'll have a test on this when we get back in April. Okay, right, I'll talk to you later on in the week. Have a great Paddy's Day. Any questions at all, email me. I'll get back to you straight away. If you're struggling on a particular question, you want me to put in an audio note or write a few extra notes into the question to help you get through it if it's annoying you, that is no problem at all. Okay, mind yourself. Take care. Bye-bye.